So let me start from here then. So by default, when you load Cura, you might have here a different name. So that could be depending on which printer it is set up to load at. It could be default, it could be any random name. For me, this appears as a Creality CR10 because this is the printer I have here in my apartment. So of course, what we are going to be using, at least for now, and if something changes, I will let you know, will be the Ultimaker 5. So this is the printer we have in the chair. And that means you have to go to settings, printer, and add a printer. So this is where you go to add manually a printer from the list. And here you have non-network printer. So I don't have the printer connected to my network. So I added from a list. And you have here Ultimaker S5. This is the printer we have. This is the printer we will be using. So just by clicking add, this could take a few seconds. And what happens is you have here the name Ultimaker S5. For my case, it says number 2 because I had number 1 previously added. And you see here there's a visualization. So you can see kind of an aluminum chassis here, kind of a structure under the build plate. So this is actually how the printer looks like with the dimensions of the printer as they are. So the dimensions of the printer, meaning the widths and the depths. And you can see the logo here or the name of the company Ultimaker. So this is the very easy first step. Just load Ultimaker 5. The second important thing is the Ultimaker 5 has 2 nozzles that are extruding, so 2 extruding nozzles. And you can see directly here next to the printer type, the nozzles by default. In generally, you have AA04 as nozzle number 1. Sometimes by default here, you have a BB04 rather than AA, as you can see in my case. So a BB nozzle is the default case. I adjusted it to A. To go back to default, you click on any one of those. You click on here nozzle number 2, and you switch here print core type, which is the nozzle type or the core type, to BB04. So that's by default how it usually should look like. Also here, the material by default is usually PVA. So default, it should look like this, AA04 PLA. Generic means like the default type of PLA. And generic PVA BB04. So this is when you have a new Ultimaker 5 and you just loaded it for the first time. This is very important to set up here and set up those, because this is what will be on the printer physically. And if I send the file to the printer, the printer will compare the content of the file to the setup of the printer and will say, okay, I do have those nozzles, I am ready, I do have this material installed, and I can start printing. If you adjust those settings to something else, it might give an error or a warning and say your file is for AA08 and I have installed AA04. So you have to have a compatibility thing. So by default, use what you have. It should be A04, BB04. And there's nothing else to do to set up the printer. That's it. That's all you need for now. Later, when we get to the file and we do the slicing, then we look into how we save the file and how do we send the file to the printer. That is also an easy step. So from here, I'm going to load an example STL file. So that is usually very easy. You just do file open. You go where you expect to have some of those files. So I have here some of your example designs. I will take any STL file I've received from you, and I will load that as my example. So I have here a file from Ali. It's an STL file, and the rest are images. So of course, you need to load the STL. And just by loading it, you get the file in a random orientation. You never get it in the perfect orientation you expect. So first step is you need to position it properly, orient it in a better way before you start working with the setup or the slice parameters. To do that, it's very easy. Just click on the part. And the first option by default is positioning. So you can put numbers here to adjust the position, or you can click on those arrows and drag it along the direction you prefer to have. In this specific case, I don't need to actually reposition. The second option in the menu here is to scale it if you need the part to be larger or smaller than the original CAD. That is not common for usually the design. Usually know exactly what the scale, what is the scale you need. But you would actually use this if you know that your material has high shrinkage. Some material that shrinks 5%, for example, you could go here and scale it up 5%. And then when it shrinks, it goes back to the original intended dimensions. For PLA, the shrinkage is something near 1%. So I'm not going to adjust those. I'm going to leave it as default. But we still need the third option, which is to reorient. If we click on it, this is the snap rotation. So default, this is on. And that means it will rotate 15 degrees in steps of 15 degrees. For such a part, based on what I see, I would think maybe this is the best orientation to print it. Maybe this is one orientation, but it could be better if we can lay it down on this surface. So you can experiment with the better orientation to try to find an optimal one. Of course, in this case, it seems support could be probably unavoidable, but I cannot confirm that now. And if I click here, I can reset to original position and try again to find the proper one. So for now, I'm going to go with this default orientation. As I said, this probably is not the optimal. Maybe laying down on this surface is better, but then you need supports here. We'll see. So for now, I'll leave it like this. And now I got the part in place. That's a step ready. Now, where do I go from here? Now I have to go into the parameters. And you see here a tab that already suggests what are we working with. The default layer height is 0.1, but we will be working with a thicker layer height. So we will be printing our components with 0.2. So to get the menu for more options, you just click here. So you see 0.1 is a layer height default. 20% is the default infill. And this is usually supports off. And this is also additional base material. So what this is that there is extra material added around the part to increase the area footprint of the part so it sticks better to the bed. So when you see these, you have an idea of what the setup is, but all the parameters are actually in this long list here. And you should be careful that this long list is now for nose number 2, nozzle number 2, but we're working with number 1. So we click here, and now we switch to the nozzle we need. To be sure that the part will be printed by nozzle number 1, you can right-click on the part, and you can see here it says Extruder 1 PLA. So this part will be produced by Extruder 1 PLA. So that's just the first checkup step. Now we start to adjust with the parameters, and I'll explain what those parameters are and why do we need to adjust them and what difference will that make. So first, we have here fine 0.1. We want to go to 0.2, so we click on this drop-down menu, and we switch to fast. So these components are intended to be produced fast with a relatively thick layer height. So a nozzle of 0.4 will be depositing layer height of 0.2, which is kind of an optimal, decent value. What else you should consider or remember is that you have this small box here that I've shown you maybe before. And in this box, the default state is usually basic, which means this list of options is shortened to the basic options you need. And you can extend it to advanced knowledge. So there's more options there to look into and learn. And you can go to expert mode, where you have a much longer list with more options. And some of them are beta tested. And you can also go to the extreme of all that includes every single possible option in the parameters. And you see the list is quite long. And here you have also some closed menus, so it gets even longer. But these are for dual extrusion, which we will not be doing. This is for some mesh fixing if you have some major problems with the original STL file. These are special modes. So these are experimental methods of printing. They don't always work well. And these are also experimental methods. So special modes and experimental, they are both not so consistent. They are always in, or almost always in beta testing phase. So you need to expand the menu to expert, at least for what we're going to talk about today. Of course, you don't generally need all of that. but there are some important things to mention. As soon as I've switched to fast, the infill has automatically switched to 15%, so it automatically reduced the infill. And now what we need to do is close all those tabs. So we have a shorter list, and then we go through them one by one. So you see, this is the list of options that we have. So we have quality, shell, infill, material, speed, travel, cooling, support. And these are the main ones you need. We have the build plate adhesion. That's what I said about the footprint, and the others that I already mentioned. So always you start with the first one, quality. What do we need to change, or what could we need to change? So the layer height, we do not need to change that. This is what we intend to build at, 0.2. And the first layer, the initial layer, could have a different height. By default, it is generally slightly higher, so it's generally 0.27. And that is usually so you don't press the plastic too much on the glass, and you wouldn't make it too difficult to remove. But for stability, I generally keep it as a default 0.2. And that automatically means that removing the part off the glass could be slightly difficult. But I prefer to have a difficulty removing the part rather than the part detaching in the middle of the print and moving around the plate while it's printing. The line width is usually the default diameter of the nozzle. It could be slightly smaller, and it could be slightly larger. So smaller meaning up to 0.35, and larger usually not more than 0.5. And that means that the nozzle will deposit a line that is wider than the tip of the nozzle, or the hole in the nozzle, orifice of the nozzle. So a default of 0.4 is okay. Sometimes a default of 0.5 is better. But for this, for consistency, we'll keep the 0.2 and 0.4. This is not necessarily optimal. Sometimes you need to test several parameters to find the optimal one before you start producing components. And you also here have the top and bottom line widths. So again, you can adjust the width of the line only for the first layer and for the last layer, so top and bottom. So these are specific for different layers. As you also know, this will be built up in layers. So usually the rest you don't need to adjust. So what's extremely important to look at first is the layer height and the line width. These are the two parameters to look at first. That's done. We move to the shell. So if we look at this component, it will be built by an external contour and then internal lines and internal lines, concentric lines, to have a shell. And then inside that shell, it will be filled by an infill. To visualize, before I keep going through these options, I will slice. And you don't see any changes because we're still in the prepare phase. So I switch to preview. And in preview, I already see the layers being built. And I can use this menu to move through the layers. So as you can see here, I'm moving through the layers. And you can see how is the part filled with material. So as we are building the external shell, we see the internal gaps. And this component as an STL is already empty, right? So this is your empty STL. Usually you have it already a full solid body. And it is here removing material from the inside. That means when it comes to the shell, we have one red line, which is the external surface, one green line, which is the supporting additional layer, and then you have the infill, which is in the orange color. If you click here on the color scheme line type, you will see in red is the shell, in green is the inner wall, and in orange is the infill. And I can choose to hide the infill, or I can choose to hide the shell. So for visualization, so I can check if the rest of my strategy, my printing strategy is okay. You can also add the travel. So then you see where the nozzle is traveling while it's printing. This is not generally necessary in this case, but in cases where you're worried about the nozzle hitting the part at some point while printing, you could check the travel of the nozzle. It's very important to hide whatever extruder 2 is printing. So in case something disappears, that means you still have something printed by extruder 2, and that is a problem. You can also check that by switching. So you turn extruder 2 on and you turn extruder 1 off. If there's nothing on the plate, that's perfect. That means nothing is being printed by extruder 2. So that's just to double check. So we go back to extruder 1. We can leave those on, opened. And now we start to adjust those parameters, and you can start to see the effect of those changes. So as we already decided that the line width is 0.4, we have here a wall thickness of 0.8. And that obviously means that we are printing 2 lines adjacent to obtain a 0.8 width. If I adjust this to a 1.2 value, and then let's hope this works, and then slice again, I should have 3 lines now. As you can see here, I have 1 red line, which is the outer surface, and then 2 green lines adjacent, which are the internal ones. So by switching to a wall thickness of 1.2, I should at least have 3 adjacent lines. So I will move to a lower layer. I'm just moving here the visualization. And you'll see here how the infill is working and how those 3 lines are working. Let's go to 1.6. So now we should have 4 lines. And I advise you for your components to try between 1.2 and 1.6. So that means 3 adjacent lines or 4 adjacent lines. So this is what you should have. And so that's first value to adjust. I will stay with 1.2 for now. And you can adjust either by thickness or by the number of line. And this is the wall line count. So this is set to 3, and you can see you have 3 here. So the rest is not options that you should adjust for now. But if you hover on, you get this text in black that explains what this means. So the outer wall wipe distance is distance of travel inserted after the outer wall. So these are small adjustments to make those lines stick better together, especially at the corners when the direction of print changes. The default values are always fine. You don't need to adjust those values. So in this shell menu, you have this one to adjust. And in the extruder selection, it's good always to select by default the extruder 1. So you'll have everything decided as extruder 1 rather than left for not selected or by mistake extruder 2. So now we decided everything is going to be produced by extruder 1, 1.2, 3 lines. And you can also adjust the top and bottom thickness. So for the top and bottom layer, you can add more walls. Okay, so I'll go to the bottom layer by clicking here 1. So now I'm at the bottom layer. That's layer number 1. And if I switch for the top bottom thickness, if I change it to another value, let's choose, for example, 4, I should have 10 adjacent line. So sorry, this is for the bottom thickness again. So if you hover here, the thickness of the top bottom layers in print, this value is divided by the layer height. So this will decide how many layers are considered bottom layers. Okay, so if I wrote 4 millimeter, that means 4 millimeter upward from the plate, all of those layers in those 4 millimeters are for the software considered the bottom layers. What does that mean? That means in the bottom layers, everything is filled with 100%, as you see here in the yellow infill. You see the yellow infill here, it's everywhere. So there's no cavitation, there's no empty space in the bottom and top layers. So that means if I switch again the bottom layer to 0.8, which means if I have a thickness of 0.2, that will be the first 4 are considered bottom. And then I go to the layer number 4. So this is still in bottom. You see it's fully filled. And now I go 1 layer above it, layer 5. So this is already higher than the bottom because that's at 1 millimeter. And you see already the infill starts to take action. So already you have some empty space and the infill strategy starts. Okay. So why would you change this value if you want the base of your part to be thicker and stiffer and the top of your part to be stiffer and thicker? You can adjust this for top and bottom, or you can independently adjust for top and independently adjust for bottom. As you see here, top 0.8, which means 4 layers, and bottom. So you can choose independently to adjust the fully filled layers. Okay, that is very useful in cases where you have tension and you want the, when you have a beam bending, you have compression at the bottom and you have tension at the top, for example. Then you would add more layers in the top and more material in the top to take the tension stresses. Okay, so you can think from engineering perspective and make such adjustments. I will not adjust anything else. There's a lot of other options, but when we look at the bottom, you see these are parallel lines at a certain angle, and these are the bottom layer pattern. So, and the top layer pattern. The default is lines, but you can also switch those to concentric. Sometimes this is not the best mechanical option. And obviously that should have concentric lines until the core. As you can see here, you'll have concentric lines going inward to fill the entire space. So sometimes this is not the best option mechanically. And you also have other options like zigzag. Sometimes zigzag is actually better. What does that mean? As you can see, the line is zigzagging to fill that space. Okay, so you can try those options, switch those options. The main effect of those changes is going to be mechanical rather than anything else. It's not going to save material or waste more material. It's just going to influence the strengths of the component at the end. I will leave it for zigzag now. As I said, there are some options that I will skip. They are not necessary. They are a bit advanced. They will not make a difference in this case. So you see here, there's some printing order optimization. It's on, default is fine. You can force the printer to start printing the outer wall, that means the red line, before printing the inner wall, the green line. And sometimes you can switch it to the opposite, so it prints everything inside, and then at the end prints the outer wall. So this is just the strategy or the sequence of printing that will not affect too much, again, the strength. It will just affect the surface finish, the quality of the print a bit, the kind of aesthetic parameters rather than mechanical function. Again, nothing else to adjust until this one. So sometimes in the structure, there are some gaps. So as you can see here, there's a small gap. And sometimes there are larger gaps than those, not just because of infill, because of the STL geometry itself. For consistency in the print, it's better to keep this as in nowhere. So don't ask the nozzle to go to those small points that are empty and try to fill them. So the nozzle will try to go into very narrow areas and try to inject material there. And that sometimes creates some surface defects and some internal defects. So it says here nowhere, and then in the approach, filter out tiny gaps. So the software will ignore those tiny gaps. So this needs to be switched preferably to nowhere. Again, we can skip all the rest. There are a lot of features you can always hover and read about, but I'm only focusing on what's very important for now. Always have this off, so it is by default off, and it should not be on. Ironing means at the end of the print, the nozzle will be heated up like the iron when you're doing your clothes, and it will kind of clean the surface of the part by moving the hot nozzle on the surface. This is called the ironing step, and this is only done again for aesthetic reason to have a bit smoother surface. That's it when it comes to the shell. We're done with shell. We can go now to the infill. So again, it's always good to by default switch and force the printer to use extruder 1. Sometimes if you don't do this, it will select extruder 2 for the infill. And if you don't have any material in the nozzle number 2, it will not extrude anything and the part will be empty. So always, in this case, we're always going to be using extruder 1. So always select extruder 1 as the source of your material. The default density for fast was 15% infill. So again, I guess by now, if you switch to 30%, the infill quantity inside the part will be increased. Let me move this. So as you can see here, so now this is about 30% infill. And by default, this number is calculated from this one. So when you see there's this shift in the line, that means this value is mathematically connected to the value before it. So if you adjust here to 50, the lower number will adjust with it. automatically. And now we went to 50% infill. You can see how much more infill there is. But you can notice that the lines here are in gray color. This is just a visualization thing where it hides out a bit the colors so you can see the specific layer. And you can show the rest again by just switching to another layer and coming back to it. Then you can see again all the coloration if that is necessary. The pattern by default is triangles, and you can see here these are triangles. But besides the pattern, there's also this very important feature here, which is connect infill lines. And that means when the nozzle moves until this area here, it goes up and connects to the next line, and then connects parallel to the wall to the next line, then again parallel to the wall. If I turn it off and slice again, you can see the difference. So you see now it reaches that point and then stops extruding, moves to a new position, then continues extruding, then stops, moves to a new position, then continues extruding. So for consistency, for a homogeneous flow of material, it is always better not to stop and start extrusion. So the nozzle is always moving, but it's better to keep the material flowing through the nozzle consistently to get a consistent flow. So it's better to keep this on again for a better quality of the extrusion. Okay, and for the rest, there's a lot of small adjustments. Before I keep going forward, of course, there are different types of infills. Triangle is the default, but it's not necessarily the best. It depends on what is the function. Concentric is not so good of an infill option, as you can see. Maybe it is useful in case if you have compression maybe in the part, but it is not so well connected. You'll have internal shells inside your part, and these will not reinforce it good enough. You have a common type of infill called gyroid. This is mostly considered weight-wise efficient, but it's not always mechanically the best, and it doesn't always print perfectly. I would generally advise to avoid it. A good type is the zigzag. And zigzag has, you see a 45-degree angle, but it also switches the angle at every layer. So if I go to layer 9, you see the angle has switched. If I go to layer 7, that's the angle. And 6, it has switched again. Then 5, and it has switched again. So it switches 90 degrees between every layer. And it's always more or less best not to have all the lines in the same direction. So this kind of 90-degree switching between layers has usually a better mechanical result when it comes to also shear loading. So you are all mechanical engineers, and I assume you know what a shear loading at 45 degree is. So these are good if the part has some shear loading. So that's it for the infill. The rest doesn't need to be adjusted generally. Again, you can always hover and read. I will not adjust much, but you can see here there's this angle, 90 degree, and you can adjust this angle here to have different orientation at which it will switch. Let me see if this works. 20 degrees. Let's see. So this needs to be activated. Okay, this is the connection for the skin. So this will not adjust here. And if it's start here, actually I made this mistake. So here it's the infill line direction, and you usually can choose the angle here. And you can choose the angle for each layer. So you can choose the angle for the first and then the second. And you can see here the angle has changed from what was default 45 to what's now close to 20. I think you can add a comma and add 80. That will be the angle for the alternating layer. And let's see if that works. Yeah, so you see now I rotated the intermediate layer to 80 degrees. So you can have a selected angle, a preferred angle, and you can choose that angle by having those values inserted here in the line direction. Of course, the default is the 45 alternating at 90 degrees. So that's it for the infill. Now we go to material. This is a very important step here. For printing PLA, generally the default temperature is 205. But for better adhesion between the layers and better mechanical performance, it's better to increase the temperature slightly. So we'll increase it to 210. And that will be the printing temperature. The first layer is usually printed at slightly colder temperature, so it will not stick too much to the glass and will be slightly easier to remove. And the build plate, the glass surface on which we are printing, is for PLA at the default value of 60 degrees Celsius. So that is the recommended temperature for the build plate. Of course, if you're printing some polyamide material, this could be 80 degrees. If you're printing some ABS, sometimes it's good to go to 120 degrees. If you're printing some material that has a lot of shrinkage, something like polypropylene, sometimes you could set this to 0. So you'll leave this cool and you'll print on a cool surface. It depends on the material. For us, we need 210 and we need the default 60. You have here an additional very important value, flow, and that means theoretically, the software is calculating how much filament should be pushed into the nozzle to extrude the needed quantity. Theoretically, the world functions perfectly. Practically, the world doesn't. So the filament sometimes has difficulty moving, difficulty flowing, some material diameter is varying, whatever. And sometimes the nozzle, if it's extruding fast, it will cool down, and the heat source in the nozzle will not give it enough heat to extrude properly. And that means that your flow rate could vary, could drop. So what you do to ensure that you have enough material, and it's better to have more than enough material, is that you increase the flow sometimes to 101%, 102%, depending on the material. And that means you're extruding always 2% more than what you need. That is very common when you're extruding polyamide. You could go to 105. And it's also common when you have fiber inside the filament. You have glass or carbon fiber reinforcement. It's very common to add up to 3%, 4%. Many times the manufacturer of the filament could advise you on how much flow you should add, depending on their material, on their filament, and of course, depending on the nozzle you are using. For what we are doing with PLA, 1% is much more than enough. PLA usually doesn't have trouble extruding, and we have already increased slightly the temperature, so we expect the viscosity to be a bit lower. We expect the material to flow a bit better at slightly higher temperature and with 1% added material. Okay. So now we get to speed. So we don't need to adjust much in speed. The default speed, we're doing this fast. The default speed is considered a print speed of 70. But you can see, although the print speed is 70, the wall, which is the red and green lines, are printed at 55. Especially the red one is printed, the outer red wall is printed at 50, and the green ones are printed at 55. So for the red wall, for the most external line, you can choose to print it at much slower speed if you want to have a perfect surface quality, aesthetic quality. Okay. So the rest doesn't need to be adjusted. So as it is, as default for now, that is totally fine. For materials like polyamide, this is definitely advised to be something near 40 rather than 70. And that means if you switch this to 40, you'll see the wall speed will be 32, the inner wall will be 32, outer wall will be 29. So that's a considerable reduction for the printer. Of course, a printer is a mechanical machine. And if you do this at higher speed, you'll have higher acceleration, you'll have higher inertia, and you'll have this overshooting effect. So the nozzle will move to a new position, but will always overshoot because of the mass of the print head. So high speed, this is considered relatively high speed, but the printer can go up to 200 if the nozzle can melt the material fast enough. That's it for the speed. Whatever here is left, you don't need to adjust it. These are, again, part of the expert data. So you can set a limit for the acceleration, and you can also set a limit for the jerk. I hope you remember what jerk is. So jerk is the derivative of acceleration. And for any fast-moving machines, jerk is also as important as acceleration. That's it for speed. We'll go into travel. So an important thing to always turn off for most material, except PLA, is enable retraction. So for PLA, this is fine to keep it on. And this means every time the nozzle is done and it's moving to a new place, it will retract the filament move to the new place, and then push the filament again to continue extrusion. It does that so it doesn't keep dropping material while it's moving around. So to reduce the liquid pressure in the nozzle while it's moving around, so that there is no drops falling on the surface. For PLA, this is not so necessary, but this is not a problem. But for some materials, if you add this, that means the filament needs to pull and come back, pull and come back. And if there are fibers in the material, carbon fibers, you will be doing abrasion to the internal surface of the nozzle. You'll be, machining the internal surface of the nozzle. So you better turn that off for any fiber reinforced material or polyamide difficult material to melt and flow. So we'll keep this on for now. And the rest, again, is with the retraction speed, the retraction distance. So these are all parameters for the retraction itself. And nothing else to adjust. By default, you have the Z hop height. That's important to know, but you don't need to adjust it. That means every time the nozzle finishes a line, it moves up 2 millimeters to move to the next position. So this is just a security safety distance at which the nozzle moves away before repositioning. That's it with travel. We'll go to cooling. For PLA, it is very good to have cooling on, and you can leave cooling at 100%. If you cool the part fast, usually it shrinks a lot, but PLA doesn't shrink too much, so it's fine. You can cool it down fast. You definitely need to turn this off for something like ABS, something like polyamide and polypropylene. The default fan speed when it's on, it's 100%, so full power, maximum cooling. And you don't need to adjust much. So what's important here to know, if you're not printing PLA, if you're printing something that shrinks a lot, again, polyamide and ABS, you just turn it off. That's it. Done with cooling, we get to support. Some of you will need support, and this part, I assume, does need support. If I switch here and click on Generate Support, by default, the support is going to be printed by nozzle number 1. If it's not, you have to select it. So it could be nozzle 2. So be careful that you switch it to nozzle 1. Everything built here needs to be extruded from one single nozzle. Assume that we remove this, it doesn't exist. So now we're working with supports, and we can slice. And now I turn the supports on. By default, they are off. And I'll switch again to preview. And you see it's building this very small support here to support the edge of the part. This part is very long. So of course, if you start building and only later reach this small zone of support, this will fall off the table. Why there's no support here when you expect it to add is because of the angle selected. So we have an angle of 60 degrees, which is our limit. You have to, for this part, maybe reduce to 30 and then set again, and that will add support starting at 30 degrees, and now you have the supports there. Okay, even before you add those, at the prepare phase, if my angle is 30, you see a red zone. That means this needs support. If I switch it to 60, then it's yellow, no problem. Okay, so if I set my minimum angle to 30, the software will tell me this zone will need support. And that means when I slice it, I will not be surprised if the software added support in that area. Okay, so of course, support will consume material, will consume time, weight, material, cost. But you can also reduce a bit the concentration of support, the density. So that's why I'm going to skip a bit until here. You see here, density is 15%. So I'll switch it to, let's say, 10. And that will reduce the lines, the number of lines of support. So you see now there's few of those supporting lines. I will go a bit more extreme to 2%. So you can see a larger difference. And as you can see, I have only those reduced walls. So this is up to you to decide what is enough, what is not enough. Sometimes you can only know by testing. And usually you prefer to go for the minimum quantity before you increase. But this is only to show you that. One very important feature about support, I will be able to show you that by rotating the part. So if you look at this part, there is nothing in the way between the glass and the base of the part. Okay, there's nothing in the way between the glass and the base of the part. in this orientation. In case I rotate the part 90 degrees like this, you'll see that to support this upper area, I'm going to switch, to support this upper area, the bottom area is in the way. Between the glass and this upper area, the bottom is in the way. So here the support placement by default is everywhere. And that means if I slice, it will add where it expects to add, here and behind it. And it will also add support between those two. So that means everywhere that needs support will have support, but that means it's building material on the part to support the upper side. In some cases where you know that this will not need support, you can switch this to touching build plate. And that means it will only add support where the support is touching the build plate. So that means here it's not touching the build plate, it's touching the part itself. So it will remove the support from this area. Because if its support tries to go downward, it will not touch the build plate. I assume that is obvious. And of course, you see this such a part, there are two problems orienting it this way. First, of course, you'll need to add support here, and that's consuming material. That's one problem, not the biggest problem. The bigger problem is that you'll have the layers on the base here along this orientation. And when you have stresses, tension stresses here, these layers will delaminate, they will separate. For mechanical purpose, it would be better to rotate it this way, at least for the base perspective. And now if we go into the base layer, if the tension is here in this area or in these corners, the tension is along the line. The tension is along the direction of the line. So that's what I was trying to explain, that you have to orient the part when you slice it. So you have the tension along the line, not perpendicular to the layers. If the tension is upward, perpendicular to the layers, then you'll have delamination, okay? So that's something you need to consider at the base for such a part. But then when you move forward, you have the problem in the fork, right? So the fork is built by those layers. And if you have tension, you're trying to bend that fork, you're trying to bend that, you'll have tension that will delaminate the layers. So this is an optimal orientation for the base, but not optimal for the fork. And if you rotate it 90 degrees, it will be optimal for the fork, but not optimal for the base. Maybe that's why 90 for the base, this orientation is not perfect, and 90 degrees rotated is not perfect either. So you have to find somewhere in between an optimal positioning for the part before you slice it to get better layer orientation, to get better mechanical strength of the part. Okay, so that's all what you need to do and to know in support. So you turn it on, you select nozzle 1, and you switch between the options of touching build plate or not, and then you can adjust the percentage. Zigzag is fine. You can again switch between different types of lines. Zigzag is usually fine, it's okay. And generally, you don't need to adjust most of the rest. Okay, so there's a lot of other options. And you can usually adjust those after you print. So you might notice that the support is sticking too much to the part. So you'll find which parameter could reduce that. For example, the gap between the part and the support, there's a value here we can adjust that gap. And if the part is sticking too much, you increase the gap. So sometimes you can only know the best parameters when you do the printing, right? So you start the first print, you improve it for the second print, and you improve it for the, maybe it takes 10 iterations. And then you have the best parameters, and then you start producing components. That's it for the support. We get to the last part that I need to mention for now, and it is the build plate adhesion. So the first point of that has nothing to do with it. It's called the prime blob, and usually it's better to keep this on. If you hover, you will find the description. That practically means that the nozzle will extrude some material here in the corner, just to be sure that material is flowing, just to prime, to prepare the nozzle to have hot material ready at the tip. It will extrude a small quantity here and then go to the build area and start printing. I think if I slice, I'm not sure it will show that. I think it would not. Okay, so it usually doesn't show you that additional prime volume or blob that it extrudes here. The second option is the default brim, and brim means adjacent lines. So you see those blue lines, they are next to the part, and the intention here is to increase the footprint of the part so it sticks better. The other options are a skirt. A skirt is just a line around it to inform you where the part will be built. So you see this skirt line here, it has two functions. It prints the skirt first, so you know where the part will be printed. And while it's printing that line, it's already priming the nozzle. It's preparing a homogeneous flow so it gets continuous good print. Skirt is almost not that helpful unless you have several components on the same plate. Usually default is to go with brim for PLA, for something that doesn't shrink too much and doesn't need too much adhesion. There is one more option called draft, and that is usually very good, very useful for material that shrinks a lot. And that will print actually a complete plate under the part. And when it's done printing that plate, it will print the part on it. And that plate isolates thermally also the part from the glass, from the surrounding, and distributes the stresses at the base so that any shrinkage happens in the plate of the raft rather than in the part itself. So this is to reduce a bit the delamination risk and to increase, again, the footprint. And you can always go with the option none, and that means there will be nothing at all around the part. It will just print the part going up directly. Of course, this is not a good option. It's always better to go with brim, and be sure that it's extruder 1, as always, for every step. And you can choose how many lines. You see those blue lines, you can choose how many. By default, they are 7. You can choose to have more or less, depending on the dimensions of your component. And that will be mostly it from this sequence. One last thing is, as you can see the part here, you already know how you can adjust the view. You can also here switch from line type to material color. So you can see that everything is yellow. Everything is going to be material number 1. And you can switch to speed. You can see the average speed of printing everything. So the base, the brim is usually printed at a different speed. So you can see much slower, and then it increases. Okay, so that is in many cases important. And you can see the infill here is also printed at a different speed. And you can also see layer thickness. I have everything printed at 0.2. That's why everything has a consistent color, right? It's 0.2, 0.2. There's no deviation in thickness. So there's nothing to adjust here. A feature that's not always useful, but maybe in your case could help, is to look in X-ray. And you can see if there are internal defects in the component. If you have some empty area or some additional part hidden inside your part, you can see that in the X-ray, because sometimes there are those defects and they cause a problem with the slicing. So if your mesh is good, you don't need the X-ray. If you have a messed up mesh, you will need that. So that's it. We go back here and we switch back to line type, and this is the default view. Now, last step is after we sliced, and I don't have any USB plugged in to my PC, so I just need to click Save to File, and I select the location I want to save that file. The default file type is UFP. UFP is a special file type for Ultimaker 5. So if you send that file to anything else, it will not read it. But you can also click on the drop-down, and you have to switch to G-code to have a file type that you can edit, a file type that you can read, that you can adjust. Okay, so important step is to switch to G-code and save as both versions, UFP and G-code. And if you have a USB plugged in, automatically the button here will say Save to USB, and it will save the file directly to USB. And you will have a small drop-down menu here, so you can switch from USB back to saving on your PC. And that is mainly it.